Google Hangouts is not. All right. Hello, everyone, and welcome to the Robot Party. So, the Robot Party, in case you don't know, is a Google Plus Hangout where a bunch of us robot builders get together, show off what we've built, discuss ideas, and see where we can help each other, of course. Um, so, the Robot Party takes place every now and then, and you can stay up to date on our Google Plus community page, which is the Robot Party Rockstars. And this week, or this Robot Party rather, the theme is how our robots can help improve the environment. And so we've got a bunch of robot builders here lined up, and yeah, let's go for it. So first up will be Dan. Oh, sweet, Albert joined. Dan, are you able to, is everything working there?
Yeah, everything works. I dumped a soft drink in my keyboard earlier, so I had to go get another one. But other than that,
Do you have a video?
yeah. Y'all seeing me?
No.
Oh, wait a minute. My webcam's not working. Hold on. I don't see the blue lights. Now, how do I fix this?
All right, we'll come back to you.
All right.
Cool. All
I'll get
right,
it.
Michael, how is RoboGames?
It was pretty cool. If you didn't go, you kind of missed out. There was lots of stuff going on. Of course, you had the big BattleBot arena. That was really noisy. This year, instead of being in San Mateo, it was in Alameda, on the Alameda Fairgrounds. So there was two buildings. One had the big BattleBot arena in it, and it was, every time you go in, it was really noisy in the pit area. And the other one, the building had sumo line falling, the humanoid area, in the pit area. Oh, the big thing David Calkins.
Oh.
These are the medals. He outdid himself this year on the medals. I don't know if you can see him. That's the robot side. Side.
Cool.
So the medals were cool. There was a lot of people there from Korea. Of course, the Farrells. A guy from Taiwan with his what he called Fuzzy Buster. It was actually a 3D printed humanoid robot. It was very competitive.
Wow.
So it was very cool. We had a little memorial for Lim from Robot Dreams. His family showed up, and it was kind of it was kind of sad and touching moment when his family was there. Right, his son and his daughter and his grandkids. So, I mean, it went really well. I would encourage anybody who hasn't been to RoboGames to do it next year. I still think it's going to be in the Alameda Fairgrounds. It's not Alameda, just right across the bay from San Francisco Airport, so it's really not that hard to get there. But you do probably have to rent a car. You just can't get a hotel and use the shuttle back and forth. So, now, if anybody has any questions about RoboGames, what was going on, but it's a yearly event. Usually happens in April, usually around the second or third weekend of April. It's a weekend event. Usually is representatives all over Brazil, Mexico, Japan, South Korea, U.S., and Europe, so on, and all kinds of events. The big one is the BattleBot, the huge BattleBot arena, with all different weight classes. They have the little smaller weight classes. Mech Warfare was back this year. I don't know if anybody knows a lot about Mech Warfare, but it's basically like a tent with buildings in the middle, and the robots move around and shoot each other with little pellet guns. And then, of course, the like I said, in my building, there was sumo line falling. There's a firefighting contest where you find the little candle flame and put it out. All the humanoids, kung fu demo, so on. So I mean, I think that's about it. Unless there's some questions somebody has about robo games and how to get involved and what to do with it. Like I said, the medals were super cool this year. They're really worth. David went out of his way for the medals. So.
Sweet. I have a question. So, like, if there was one of the categories that could be most applied to, say, the environment, because, like, that's the theme this week, which ones do you think they would be?
I think probably the best one would be the firefighting robot, because the people you put them in a maze and they have to find the fire and put the fire out. So I think that would be have swarms of firefighting robots rolling around putting fires out. So make it safer for humans. Like maybe remote control them.
Yeah. Did any of the ceiling tiles get damaged this year in the arena?
Yeah, I mean there was a lot of action going on. I wasn't able to be over there all the time, but yeah, definitely the arena got beat up. There's the flamethrowers and the spinning robots flying around and making all the noises and stuff. Yeah, it was. If you haven't seen the TV show, the BattleBot TV show is very close to what Robo Games is like with the warfare. It's just constant. It's from 7 a.m. to like 6, 7 p.m. It's just constant battles, one after another, after another, after another. So yes, the arena got. I don't actually got a hole in it this year, but yeah, it was definitely beat up this year.
Wow, cool. Just in closing now, do you have any thoughts on how robots can help improve the environment? Like you mentioned the firefighting ones. Any other ideas?
Sorry. I would think as humanoid robots become more and more larger and more capable, I could see them in like or even a tractor wheel robot. I could see them the firefighting area. I could see them they can police in like for all the endangered species. Maybe you can have the robots police in those areas, making sure that nothing happens to them. I mean, the big thing is that they can do stuff. They can do dangerous stuff that humans, may not. Other than that, yeah.
Humans shouldn't do, but sometimes. Yeah. Cool. All right. Thank you, and thanks for that update.
Yeah, no problem.
All right. Next up, we'll go to Robot Goldfish. I see you have your whole robot family behind you.
A good chunk of it. I haven't been able to do much. My latest project is I'm making a Root 2 CNC machine, which is printed parts. It uses square aluminum extrusions that go into the hole here, and little bearing blocks that will ride on top of the corners of the extrusions. But it's nice corn-based PLA. That's about the most ecological I can get for this week. Actually, having fought fires, Well, I'm interested in the firefighting robots, and I want to build one. Um, it's until something that can just breeze through that last DARPA challenge. It's not going to happen, and unfortunately, people are cheaper than robots. So it's kind of depressing, but I don't see robots making big strides in ecology soon, because we still got to feed the people even if they don't work.
Interesting point of view.
It's, well, how did Dr. Horrible say it? It's a stinking cesspit that I need to rule. We got to get that robot army built so we can take control.
Mm-hmm.
But no, I'm afraid I don't have much to add because I've just been busy and not had much time.
Also, I think Janie likes your microphone. Nice.
Yeah, I got it at Hamfest and just rewired it for the computer.
So as a...
Which counts as reuse.
There you go. Yeah. As someone who has, you said you were had experience with fighting fires, would you have ever thought of some sort of technology that would be able to help you? Maybe not necessarily a robot.
It was a long time ago, and since then, this little thing called a smoke detector has been invented. And if people put the batteries in the smoke detectors, that'll help a lot. And it, again, the weak thing in the system is people. It always is. But I can't really think of. Well, I'm just kind of like mind fried, and I can't really think of any good gaping holes that technology needs to step in that we couldn't do better with education.
All right. It'd be interesting to explore that from a forest fire point of view too.
Well, there is drones. In this area, I'm in right on the Connecticut border in New York. They use drones now to check the power lines. And in this last winter storm, the people just over the line in Connecticut lost power for a week, or over a week. And one of the reasons why it took so long to get power back is because they couldn't check to see where the lines were broken. And they're using drones for that now. But I don't count drones as robots. They're just remotely piloted. They're radio control.
I see. Okay. That's a good application of drone stuff.
And I got to support the guy with the spear. It's that's the kind of people I used to hang out with a lot.
All right. Thanks for bringing your robot family to the robot party. That's cool. And good luck with your CNC. All right. Next up, we'll go to Dan.
Yep.
Hey, Dan.
Hey, how's it going?
Pretty good. I see you have your robot back there. That's
Yep.
cool.
That's the only one right there. Somewhat halfway, almost put together. Actually, I put a different computer in it the other day because I'm having trouble with one of them, and I'm kind of doing things in parallel. And I've got a 4-port serial card coming in for that one, and it's just a lot easier to deal with it when it's in the other room with the other computer, because you got to have another computer to do the compile on the kernel and all that on this particular machine right now. So I don't have all that stuff in here. It's just not enough room.
So tell us more about your robot. What's its name? What does it do? What do you want it to do?
Well, it's just basically it's a general purpose platform, and the only requirements I have is that it be fairly big and be able to carry at least a DLSR and a big lens, and I wanted it to be I didn't want to use oh, I don't know, ultrasonics and things like that. You know, stuff that's been around quite a while. It's got a Z camera on it and a LiDAR up on the pole there that spins around. And basically, I just wanted to, you know, build a platform. Actually, I want to make my mobility scooter a self-driver at some point, and this is a test bed for that. It costs quite a bit of money to get the stuff built to do the steering on there, and I didn't want to put that money out, you know, unless I knew for sure that I could make it work. So this is kind of leading to that. So I like to take motorsports pictures, and those tracks are huge, and I can't walk around them without the scooter. But finding just the right line with that scooter is a real pain because you got to stop, you got to move the seat around, you got to look through your camera and see if you got it. And if you don't, you got to turn around, move up, and all that. So I think, you know, if I had a Bluetooth headset on and a smart mobility scooter, all I have to do is say move forward a few feet or whatever to get that. And I could still have my, you know, my camera in my eye and be watching all the time to see what was going on. So it'd be a lot easier to line things up with it. So.
Wow, so that really helps with you to be able to take photos with it.
Yeah. Oh yeah, it would be really, really, really cool. And besides that, you know, I've got health issues, so if I keeled over, you know, I could have some kind of sensor on that to haul me to the nearest first aid deal or whatever. Might save my life. Might be a life-saving robot. Who knows?
Does it actually have GPS functionality on it right now?
GPS, IMU, the Z, and the LiDAR is the basic sensors. It's got some weather-related kind of stuff, you know, temperature, humidity, and all that on it too. Just stuff that I had on. I actually had it for a dew heater controller on my telescope. That's where all those sit.
Huh. Oh, are you still there? Oh no, I think we lost the connection. I hope the robot will help. Okay, well, hopefully Dan will rejoin. That's too bad because there's more to the robot. So frustrating.
Yeah, I wanted to ask him about what he's programming, what you know operating system he's using, or using what the Raspberry Pi, whatever.
I think he's definitely using ROS, but I don't know more about the controller.
Yeah, because ROS, that was the big talk of Robo games. Everybody's looking into using ROS on the Raspberry Pi.
Oh, nice. The Pi Zero or just?
The Pi 3.
Oh, right. Okay. Cool.
There was a couple platforms. Usually, there's a couple of vacuum cleaners that have they're like under $500. You know, the little robot vacuum cleaners.
Yeah, like the
already have LiDAR built into them.
Mm-hmm.
And then you use the Raspberry Pi and ROS to control it. So
nice. All right. Well, hopefully Dan will rejoin. Hopefully, fingers crossed. I was interested in knowing what mechanism he used for the drive. Oh, yes, you're back.
Yeah, my internet went down for some reason and it just came back up. So.
Okay, great. Michael had a question.
Hang on to somebody else if you want to come back. It's no big deal, whatever. If somebody's already talking or whatever.
Michael had a question for you.
What's that?
I was just curious. So you using ROS?
Yes, I am.
Oh.
Yep, ROS, and I'm an old Unix system administrator, so you know, I kind of got half of it under my belt, so I figured I'd go that way. I really like ROS. It's really cool.
Yeah, everybody at Robo Games was talking about ROS. ROS is becoming really big, especially like hearing all about it on the internet. Everybody on my Facebook, and everybody's going to ROS now. So cool.
Oh yeah, you know, I've spent most of my career doing communications, and these robots, you know, are just chock full of good communication stuff. I mean, you got every kind of communications bus in the world on them. So, you know, it's kind of right up my alley. But, you know, I've been fooling around with ROS now probably about 6 months, I think, and I'm just now starting to get my head around it. And it's a powerful system, and it's got some very good debugging tools. I mean, you can simulate everything you need to simulate before you ever spend a dime, which is, you know, I mean, these things cost a pretty good bit of money, you know. I mean, if you've never built one before, it'd be nice to know that you can make it work before you go out and you know, throw your savings at it or whatever.
Yeah, a lot of the not all the robots, but many of the robots at the DARPA Robotics Challenge was using ROS and a simulation program like Gazebo. Is it Gazebo?
Yeah, Gazebo, and then you've got RViz and RQT also that you use to look at the messaging and pass messages back to it, things like that. It's a really complete system. The debugging stuff is what I really like. I mean, I was thinking before I really learned about this stuff, man, this is going to be really difficult to get into these streams and figure out what's going on if something is not working. But they have all that covered pretty much. I mean, you can see anything you need to see graphically or on the command line pretty much.
What learning materials did you use to get up and running with ROS?
There's a couple of books. Probably the best one is the one that just came out that O'Reilly just put out, Learning ROS. Let's see. This one right here. If you can, whoops. You can see that. That's right there. That's probably the best book on ROS out there.
Great.
You can get the PDF version and whatever. O'Reilly's got it. I ended up getting the early release, but it hadn't, you know, I hadn't really changed that much. I mean, there's a few new diagrams and things like that in it, but other than that, it's pretty much the same deal. But you can go back and get the one that whenever they release it, you just go back and re-download it.
Cool. So tell us more about the robot. What sort of drive system does it use on it?
There's a couple of Robotique 2130 with the CAN bus controllers on there, and what I'm doing is using the one for the front two wheels and one for the back two wheels. The reason being, that way you can use the internal mixing algorithms in the controllers themselves, and you don't have to do all that manually. Initially, I was going to do it with the, you can load scripts into those controllers to augment the firmware. So I'd written a script and was running it on the master controller that took the inputs from the radio and then figured out if there was any. Basically, you add or subtract the steering value from your throttle value to get the tank steering. So I had that working, but then I started thinking one night, I said, man, I don't need to do this. All I've got to do is go from being side to side, a controller on each side, to the controllers being front and rear, send them the same commands. You can start multiple instances of the node that runs them in ROS. All you have to do is a few little tricks in your launch file to make sure they're in separate namespaces. And it all just works. I mean, the command bell, the velocity messages are going to go to both of them. And the feedback stuff coming from those guys is going to go back to the master node. It's all done for you. You don't have to do a thing that way. So if you're going to do a four-wheeled robot, make one of your controllers the front wheels and one in the back. And everybody that I asked before I decided to do it this way told me to do it the sideways way. So, I don't know. Maybe it won't work in the end, but it sure seems like it's going to be a good way to do it.
So if one side gets stuck on a rock, how does it course correct to be able to go in a straight line?
Well, eventually it'll be able to go sideways because the four wheels also have mountings for a motor to do steering on them. I just don't know enough math yet to be able to figure out the Ackerman steering and get it right. But as far as now, you can have it back up, or you can basically turn around 180 in place too. It's got enough power to do that. It's a fairly heavy robot. I'd say it probably weighs close to 30 pounds. Wow,
that's quite heavy.
Yeah, it's pretty good lift to get it up off that test stand. But see, it's fully articulated though. See the center axle here. These can move, about that far. So, it's got lots of articulation to step over things.
Nice. That was my next question. Cool. So it's a rocker bogie sort of mechanism.
Yeah, well, this can be changed over to a bogie system real easy. A couple more pieces and a little bit more of this aluminum goodies, and you could be made into that. And basically, this little rig right here holds the platform steady. There's a pivot up here, see, so it can move like that, and it keeps the platform level. But eventually, I want to put a gear in here and a motor, and use the IMU to keep the platform level. So it won't have this on the front eventually.
Nice.
But it's all made out of Actibotix parts. Everything you see there is off the shelf. And the only pieces I had to cut was I had to cut these out of a long piece of tube, and I had to get these cut. And the rest of it's just, you know, one Allen wrench, you can take the whole thing apart.
So what sort of purpose, like you mentioned photography and helping you, of course.
I want to try to enter it in some of these rescue competitions too, you know, where they go into the buildings looking for the babies and the dogs and all that good stuff. It's got the LiDAR, so the smoke wouldn't bother it, dark wouldn't bother it, and you know, there's plenty enough horsepower on that Jetson TX1 to do the facial recognition stuff with OpenCV. So, but I try to keep making it as general as possible. So you know, whatever idea popped into my mind, it wouldn't be a whole lot of effort to, you know, add that on or convert it or use it that way for a while. You know, I don't want to have to build another one next year. This one's taking a lot out of me to get it put together, but it's starting to get a lot smoother now, though. I'm pretty close to having SLAM G mapping working, probably in the middle of next week.
Nice.
So, I've been rolling around with the radio. Also, the radio's going to, you know, a lot of people say, well, that's not a robot. It doesn't have, you know, it's got a radio. Radio can be used as a training tool. You know, if you send your bot out in some, you know, deal and it gets stuck, then why wouldn't you be able to send it a signal and say, okay, you go into learning mode now, and use the radio to tell it how to get around that obstacle. So the next time it sees it, it's there, right? So yeah. I don't plan on never not having a radio. And also, if you know, for emergency stops or whatever, you know.
Yeah, that's really important to not have the robot destroy anything or get stuck.
I plan on taking this guy to Utah where there's 1,000-foot drop-offs. I don't want him going over the edge.
Right. So
there's some really cool slot canyons up there too that human beings have never been into.
Yeah, I think so. So
Thelma and Louise, right?
In terms of the theme this week, which is the environment, how do you think your robot would be able to help improve the environment?
Well, right off the top of my head, I'd say, you know, just any kind of remote sensing application, you know, send it out, look at things. You could do rescues, you know, it could do, go into an area where there was some kind of a chemical leak, you know, gas in the air, something like that. Anything that a human couldn't deal with, I mean, you could send it in there. You could put all the sensors you needed on it. There's, I think, 7 camera inputs on the TX1 board, so you could do virtual reality with it if you wanted to. Mobile virtual reality.
Neat. Maybe that will be the next thing.
I'm keeping my eye out as soon as the cameras get cheap enough where I can get a half a dozen of them or so without breaking the bank.
Yeah. All right. Well, thank you very much for telling us about your robot. Very cool. And where can people find out more about this, like see videos and stuff?
There's I have a website. It's www.elroyjetson.info, and there's another site where I've got videos. I'll have to put that up on the chat because I don't have it on that website yet where you can get to the videos. But there's 2 or 3 little short videos on YouTube of it out in the street. And I took it to the races one day, and tried to climb all the hills at the off-road remote control track, and did that all just fine. So
nice.
But I used to race those cars. I know all those people, and they kind of like the robot, so we take it out there once in a while.
Cool. Thank you. All right. Next up, we'll go to Stephen.
Hello.
Hello, Stephen. All right.
Yeah, I don't have too much else going on at the moment. I think after we last heard met, I demonstrated some stuff that I had in simulation. I've been continuing to work on like some control algorithms for like a multi robotic system. And I would actually just do a quick screen share because I am actually going to start building some robots, hopefully sometime soon. Let me see if I can screen share this. I don't know if anyone else has seen this before. I don't know if can you see my screen?
Yes, we can see it right now.
Yeah. So like I'm really interested in swarm robotics. So I'm building control software basically. And I've come up with sort of a connectivity kind of tethering system that I have in simulation right now. I had just started writing the simulation code for that. And that's on my website here. The stuff that I have on my website right now is basically just simulating an initial construction. So all of these sort of green dots and stuff, these would represent individual units in a swarm system. The idea would be that when you initialize the system, say you dropped, a bunch of robots into a situation, this demonstrates the initial sort of connectivity mechanisms behind that. So every time I click on the screen, it's sort of demonstrating the idea that you drop everything into an environment, and they all sort of self-connect in an intuitive way. And these lines that you're seeing now show these sort of connections that connect individuals along a chain, all the way up to, say, the leader of the colony. So there are a lot of things that are going on with this. There's sort of safety within the group because there's an awareness of the group and along these connectivity chains, and also for communication amongst the group too. Only very limited knowledge is needed at the individual level because they're connecting up through these parent chains. So then you're really limiting the amount of memory and processing that you need for each individual, because it's a swarm robot system, so we want to have fairly simple individuals. So that's sort of what this is showing. So I'm at a point now with this sort of initial connectivity code that I have, where I'm going to start building some intelligence into this. So at some point, I'll be able to drag, say, the leader around this environment, and all of the followers would being tethered to one another along these chains would sort of be able to follow in an intuitive fashion. And there's also the idea that using these chains, you can assign tasks and that sort of thing too. So I'm planning on using this. This is a few years old, but there's this open source project out there. It's been out there for a while, and it lists a whole bunch of components for building these tiny microbots. And I kind of figured this would be a good way to test my algorithm on physical robots initially, because they're fairly cheap. So I can source all of the parts based on this website, and hopefully now, with it being a few years old, I can source parts slightly cheaper too. You can see this. I'm not sure what that coin is there, like a euro or something, but they're all pretty small. I think they're supposed to be like 1 inch square or something like that.
Wow.
And they're wheeled. So that'd be a good way to test my system. So I'll hopefully in the future have something where I maybe have half a dozen of these, doing something physically that I can show. The control mechanisms that I'm designing are not platform specific. So the idea is that I want to be able to separate the control mechanisms from the hardware. So the hardware layer would be very separate. So then you could apply, very specific hardware code to wheeled platforms, or maybe to airborne platforms, underwater platforms, that sort of thing. So that's my plan. So yeah, that's sort of where I'm at right now. As far as the environment goes, oh, hang on a second. As far as the sort of environment goes and how this sort of might help us, I'm looking at systems that really can be used. We've spoken about search and rescue and things like that. I know, like in farming right now, like agriculture, they're doing a lot of stuff and spending a lot of money with robots for surveying land and monitoring land and that sort of thing. So I think sort of monitoring land and being able to inspect, systems and using these very simple multi-robot systems that would be sort of they're sort of semi-autonomous systems. So you would have a leader, which would be a human in control of the leader, but then all of the individuals would be under semi-autonomous control based on all of these sort of connectivity chains. And then the idea that the human leader can assign tasks. There's also the idea that all of these individuals, if you think of this like a tour group in a museum, these sort of tethered chains, they're not physical tethers. These would be sort of communication tethers. So they're non-physical tethers, but sort of like human beings following somebody around, like a museum, for instance. There's the idea that you have within a certain range of your parent that you're connected to, you would have free movement. These individuals would have free movement. And then there's also the idea of having a drop-in, drop-out system for other humans to participate within the system. So then you can lend many eyes to a situation too. If you're sort of inspecting something underwater or inspecting, a collapsed building, that sort of thing. Rather than just having, many people looking at one screen from one viewpoint, you could have other users drop in to see things from other robot viewpoints and to have control within, the range, to be able to move around their parent within a particular communication range. These are all things that I'm about to embark on figuring out, basically. But
Okay.
I'll be building a physical system to sort of test some of the algorithms that I write for that. So there'll be like some machine learning stuff, that sort of thing in there.
Nice work. It's really cool to see the simulations that you've been working on. Last time you showed one where it was like a robot arm moving, and now we see this trail algorithm for the swarm robots.
Yeah. So out on my website, you can kind of check out what I'm working on. I'll be updating this periodically as I continue to move forward.
Right?
Yeah, the other algorithm that I showed before was sort of showing manipulation, like inverse kinematics for manipulators. So the idea, I could apply that inverse kinematic stuff. We might have these robots out there with just basic sensors, but if we want to do something physical within the environment for like moving rocks around and that sort of thing, then one could use the inverse kinematic stuff as well for like a manipulation arm and stuff.
Cool. Thanks for sharing.
Yeah, I've got to figure out how to stop screen sharing now.
Google Hangouts. Yep. Okay. Next up, we'll go to John. You're muted.
There, I figured it out. Okay, so I've got a couple of a couple of mock-ups to show, and then I'll go over and show you my airplane I'm building. So before robot missions came into being, there was RDAS, right?
Yep.
And RDAS was started on, I can't see myself, so I don't know what you guys can see. How do I turn this to see myself? There we go. All right. So RDAS started with the idea of having a robot in a CubeSat format. And this is a 10-centimeter cube that is the CubeSat format. I cut this on my CNC and glued it up just so I'd have some form of reference that this is how big the robot needed to be to fit the RDAS design specifications, right?
Yep.
And that started two projects. One would be to build a robot that would fold up into this size, and the other one would be to build a delivery system that would take a bunch of these robots and deliver them someplace very rapidly so that they could do their job. So I'll show my second mock-up here. This is a foam core and poster board version of that same hardboard cube, only this one unfolds in a way that I'm working on the CAD model now to start machining this and make it work. But it unfolds into a tricycle robot. And I don't know. Can you guys? No. Never mind. When Aaron calls me and asks me to join this thing calls my phone. So I'm doing this with my phone for the very first time. So anyway, it unfolds from the cube into this format, and then the back legs unfold like that to give it a wider base of support, and it becomes a tricycle.
Wow.
Robot. So, like I said, I'm working on the CAD model of this. I have drive motors that I'm going to put in it, and I am going to make this a reality here slowly over the next few months.
Nice.
When it's all done, it will fold up into a CubeSat satellite box. Okay? So
for unfolding, is it just powered by the wheels?
No, it'll have a servo that'll do that, I think.
Okay.
I haven't quite got to figuring that out. I'm still figuring out how this hinge is going to work and still fold up into a perfect cube with nothing out here that is the hinge, right?
Mm-hmm.
That's kind of a difficult problem. So I'm still figuring that out. I haven't figured out haven't even approached figuring out how to power it yet. So the next part of this issue is building something that will deliver these little tiny robots to some place that needs to have work done. And that's why I'm building that.
So cool. Oh my gosh, it's okay.
That's here's the wing comes off right now because it's still in process of being built. There's about a horsepower of electric motors on there, a 5-foot long wing, 8 amp hours worth of batteries, and it's got 3 bomb bays. Each of one will hold a CubeSat robot built into the bottom of it. So it can either land and drop those off or fly, and these are actually 1.5 of a CubeSat tall so that they can have room for not only the robot but a parachute above them. So you can drop them by parachute as well. So there's the tail feathers, and it's got 8 amp hours of battery in it, so it should fly for about a half an hour.
Wow. Only 30 minutes with 8 amp hours.
Yeah.
Holy smokes. Okay.
So that's my environmental robot project, right? Or projects. They all work together. And I took the idea for it right out of Aaron's head, out of what she put together for ARDAS.
Nice. Great. Do you think it would be able to lift the newer version, which is like this big?
Not this one, probably. How much does it weigh?
I don't know, probably like 1.5 kilograms.
Well, this plane, CubeSats, these guys, the specification is that one of these can weigh 1 kilo.
Really?
So, and that plane is designed to carry 3 of these. So size-wise, it would have trouble picking that one up, but weight-wise, it wouldn't be an issue. It should be able to carry it.
How easy is it to fly with like a payload that's like sort of tethered to the plane?
As long as it's tightly tethered so that it doesn't swing around, it's not an issue at all. Usually the bigger the plane, the easier it is to fly.
Interesting. Okay.
Any other questions?
Yeah. What controller are you using on the plane?
Oh, right now it's just radio. I don't have a drone controller for it yet. I will probably, I've got a couple of what are called UDB5 boards. They are PIC-based boards with a GPS connector, and I think it's, well, one of them I have has got 12 degrees of freedom, the other one's only got, or 9 degrees of freedom, the other one's only got 6. And I will probably use one of those. There's some open source software around to turn those into autopilots.
Wow, sweet. And so what would you envision, like, if there were 3 CubeSat robots, what would you envision the plane being able to, like, so like it's flying and then it deploys the robots. What application do you think it would have in terms of environmental?
Well, my original application was going to be cleaning up the shoreline. In the video that I did for you for RDAS, that's what I talked about, right? And having 3 modules there was a power and mobility module, there was an effector module that would be able to pick up debris, and then there was a consumables module that would have like packaged bags in it so that you would pick up the debris and put them in these bags. And the idea was to have the plane fly out to some place that needed to be cleaned up because of some natural disaster or some man-made disaster, and drop these modules off. They would, after landing, coordinate and join themselves together, or coordinate so that they work together to clean up the stuff and bag it. And the airplane could fly back and get more modules loaded into it and then turn around and fly back and drop more off. The only problem then is how do you retrieve all that stuff? That I don't have an answer for yet.
Yeah. It'll come. It'll come.
Yeah.
Cool. Thanks so much for sharing the progress. And RDAS is still around. It's right here on my work area. So, yeah.
Okay.
Okay, cool. Thank you. All right. Next up, we'll go to Janie. Thanks for joining.
Yeah, thanks for inviting me, but I'm kind of hovering right now. I don't have anything cool to show off. I could try to lure one of my pugs over and show one of them off, but I didn't build it. Okay, I just dropped her on the floor, but she's okay. So, just to kind of introduce myself, my name is Janie. Up until about 6 months ago, I was working for a company where our primary product was building robots that did prototyping for printed electronics. And I'd gone to school for programming. I'm primarily an iOS programmer, but I really didn't like it. It got really boring because it was basically just pulling data off of a cloud and like displaying it on the phone, and I thought that was kind of boring. And I really liked going and working with the robots because you got to like touch it and you got to do stuff and it was really cool. And then I left that job and I got another job doing stuff I didn't like. So I'm trying to figure out some way of being able to get into doing robotic stuff and hardware stuff because it's a lot more fun than just doing like normal iOS programming. And just trying to figure out how to get into all this crazy world of robotic stuff.
So what mainly would you be interested in? Like what type of robot?
I don't know. This sounds really stupid, but like when I was thinking about what I would say if you asked me that, I was thinking I'd like to do like toys. Like one of the things I've got in my basement that I want to do is I want to go and I want to hack a Furby because it's got all of the different like sensors on it and it's got a little microcontroller in it. You can like hack it and have it like do stuff, and I find that interesting to have a thing that can go and interact with stuff in the outside world. And I know that that's not, you know, a super cool like making the environment a better place thing. I don't know.
Each robot plays their part. Replace the Furby's eyes with shiny weapons. Oh my gosh. And
my favorite robot that I own is a robot just like that. Its name is Stella. And it's a robo-bird.
Yeah, wasn't Stella's eyes taken off of like an Elmo or something?
Yeah, it was. They were.
So there you go, Janie. You have an idea. Oh, there's
Stella.
Oh my gosh.
Right? This is my favorite robot in the whole world.
It looks like one of the robots from like Mystery Science Theater 3000. I have to go and like build it out of things I find around my house and then use it to help me make fun of bad movies.
Yeah, there you go.
But yeah, I know this isn't exactly like robotic stuff, but I'm really interested in electronics. Like I went to school for audio engineering, and one of my dream projects that I want to do is I want to build an analog synthesizer in my basement. So I want to figure out how to design the circuit board and do all of the stuff to build an analog synthesizer. So.
Did someone just make synth sounds when you said that?
I was curious about that.
That was pretty cool. Timing? Okay. No one's admitting to it. Who has the synth?
Yeah, like my dog, the one that I dropped on the floor, her name is Delia Derbyshire, and I named her after the woman who was the audio engineer for the Doctor Who theme song, like from back in the 60s. Ah, there you are. There, say hi to my friends. Say hi. Hi.
Cool.
So yeah, that's me. I don't have anything cool to show off because I'm still trying to figure out what I want to do and how to even just get started with stuff. So if people have suggestions about how to get started or a good starter project, I would really appreciate it.
Go to a thrift shop, buy neat-looking toys, and take them apart.
Yeah.
Yeah, I like the Furby idea. I think that's probably a good place to start because it has the sensors and deep, and that'd be fun.
Yeah, and post up a video so we can watch along and and enjoy the fun too.
You could try speaking through the Furby, so maybe hack it so the Furby moves its mouth as you speak. That would be interesting. Do some kind of tele-robotic Furby thing.
This big guy here I got to convert, he's a toy robot called a Buster, who is from the 70s, one that we never could afford when I was a kid. But his arms move, he's got a speaker in him, he's got a light, which I'm going to replace with a camera, tread drive, and lots of space inside for stuff.
He looks kind of like a Cylon, except like instead of the light going across, it's going like
Like Mohawk, Yeah. Hey, Mohawk. Sorry.
Okay, to take toys apart and hack them. Cool.
You know, I spent like several years tinkering around with different things and really looking for like a project that I could sink my teeth into also. And it was by going through that kind of process of playing with different, you know, robotics is such a huge field and there's so many things you can do with it that, yeah, you know, I tried different things and things just didn't stick, and eventually something did. Eventually something sort of grasped and gradually formed over time, and now here I am. It took several years, but along the way, it meant that I got to tinker with lots of things. I learned a lot along the way too as a result of that. And what I learned, I'm able to kind of apply to what I'm working on now. And I found something that interests me and has stuck, has sort of naturally stuck, and things are moving forward slowly but surely. But yeah, and I'm sort of doing as you are, and I think many others, trying to move away from my career, my software engineering career, into something that's robotics, and trying to do something with robotics as a freelancer, say. So yeah, it's a slow road, but I think it's a good time to get into robotics. Robotics is, I sort of see robotics right now being a bit like computing was in the 80s. With all of the hacker stuff that we have and the cheap electronics, it's sort of like the bedroom programming of the 80s, and it's going to be its own industry at some point. So it's a good time to get into it, I think.
Yay! Because yeah, I see all this potential for all these things that I think we should be a big thing, and I'm like, why aren't people more excited about it? And everybody's like, well, you know, I can't find a client that'll pay me to do this, and you know, blah 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 pays the bills, and you know, it's just a toy. Blah. And I'm just like, no, this is gonna be huge. You guys need to be more creative and be more, you know, thoughtful about what you can do with this.
Oh, exactly. And I think it will be huge, and you know, with what we are all doing here and now, I think we'll be a part of it at some point, and we will be able to get paid and rewarded for that at some point. Just not quite right now, but hopefully at some point. We have to figure out a way to make profit from this.
Just not right now.
There are people making a living just doing well-watched YouTube videos.
Yeah.
So between Kickstarter and, you know, by documenting it well, and Patreon. If you're producing something that's valuable enough to enough people, you can make a living just working on it. If you're young and have a lot of energy.
All right, cool. Thank you so much for joining in, Janie.
Thank you for inviting me.
Yeah. All right, Albert, are you able to join in? Not sure.
Yep.
Oh, cool. Great. Sweet.
So it's been like forever since I came to the last robot party. I don't remember the last time I actually talked at one. I don't have much to say, but I've spent kind of the whole month of April in California. So I was also at RoboGames at the beginning of April, and I was there with my 200. Yep. So with my 220-pound combat robot. So I was actually in the arena fighting and having lots of fun. At kind of a reunion with everybody. I was expecting to see you. And then after that.
It's sort of crackling up there.
Oh, sorry. So I actually drove down to Pleasanton for the actual event, and that was about 31 hours of driving with a big U-Haul full of my robot stuff.
Oh, wow.
But it was fun. And needless to say that American roads are far better than Saskatchewan roads. So I appreciate that a lot. Afterwards, I drove back home and flew out to LA for the taping of BattleBot. So I was able to participate on a team, and we built a combat robot for the new TV show. I'm not sure how much I can actually say about that, but it'll be on ABC on June 23rd, I believe.
Wow! That's fantastic. So you were able to build a robot that will be on the show.
Yeah. So they did have a teaser episode in just last week, I believe, on Sunday, or sorry, Thursday. So you can probably check that out on YouTube. I have nothing really to bring towards this robot talk about environment or any robot games. They also have an event called Robo Magellan, where you're tasked with building a robot to hit GPS waypoints. And so this was happening outside in the rain, unfortunately, because it was raining the whole week we were there. But I think there were lots of teams from all over that participated in that. And in terms of the environment, maybe that can help with mapping which I believe what John is doing.
Can you repeat that again? I think we missed half of the sentence there. Oh no, did we lose? Oh no, he's still there.
What part did you actually miss?
Like the whole sentence.
Okay, so I just wanted to add that one event at Robo Games was Robo Magellan. And so what's involved with that is you're tasked to build a robot to go to certain GPS waypoints. The whole competition itself is time-based, so the faster you can hit these waypoints, the better. But, in an environmental sense, that would help with something like what you're doing with your robo missions, and kind of maybe help out what John is doing with his drone robot, or any other kind of thing that requires mapping and that sort of thing.
Great.
But that's all I have for now. Right now I'm just getting my bearings back from being in California for a long time.
Wow.
So how'd you do in the BattleBot arena? How did your robot do?
Which BattleBot arena? I can only disclose.
We were at Robo Games. Did you compete?
Yes. Okay. Yes, I did. I went 1 and 2. In both of the matches that I lost ended up in smoke. So the first one, my motor wires got so hot that they fried and touched each other and shorted out, and lots of smoke there. And in the second one, one of my actual motors just burnt out, and it took the ESC along with it, unfortunately.
Wow. The motor wires got so hot that they shorted out.
Yeah. That's what you get built cheap, but then again, how much money do you put into a hobby like this with the expectation that your robot does get destroyed?
Very true, very true. Wow.
But
that must have been quite the experience, though. Did you get any help from any other teams?
The nature of the whole RoboGame family is if you ever needed a hand or anything like that, people will do or lend you a hand with tools.
Yeah, so the nature of the RoboGame family is they'll lend you a hand.
Yeah, absolutely.
Cool. That's great. Okay, yeah, thanks for sharing. And are you still going to be building an improvement to your robot?
Yes. Right now I'm trying to work on building my own speed controller. The only reason for that is based on cost. It's a lot easier and cheaper for me to build my own than just buying a whole bunch of stuff and having it burnt out all the time.
Cool. That will be helpful, especially if it's open source to everyone.
That'll be the point. So I'll open source that, and whoever wants to build it. Don't sue me if it blows up, though.
Right.
But that's all I have for today.
Cool. Thank you. Thanks for coming on and sharing.
Thanks for having me on.
Great. Okay, so for my robot, it's so this is the Robot Missions robot platform robot, and what it's designed to do is to help improve the environment. That's its main purpose. The first mission is actually clearing debris from shorelines. So it has modular mounts on it. This here is for the arm. Right now it has the soil sampler arm attached to it, but we also have a claw that we can interchange for being able to pick up medium-sized debris like plastic water bottles and things. And then in the updated version of the robot, there will be this excavation system just below the base here that will be able to drop down, and it will have a rotating auger that will be able to sweep up all the debris into a container. This is the drive system. It has a tilt functionality that's controlled by the independent servos. So it's able to adjust its center of gravity, which actually comes in surprisingly useful when going down trenches, which there's sometimes a lot of on beaches because of runoff water, like especially during rainstorms. It all follows the same trail to go back into the lake or the river or whatever. So this right now is on Kickstarter. We're trying to fund a mission pilot where the idea is that we'll develop the robot platform far enough to be released as open source so that other Fab Labs, places in the world, communities, are able to replicate this and deploy it in their own local communities. The actual mission pilot, that will be collecting 5 kilograms of debris from Toronto Island. So we have a team of collaborators where we're working on this and iterating over multiple field tests. So hopefully by the time the next field test is, there will be tank treads that I'll have made on this, and other team members are working on the environmental sensors for data logging, as well as the next revision of the claw, and software for remote viewing too. So yeah, if you're able to, it's helpful if you're able to back the Kickstarter and also share it with your friends and network, so that hopefully we can get these robots out there in the world and replicate the robots with the plastic that's been collected. It's a sustainable robot in a way. So that's how it helps improve the environment, by collecting shoreline debris. Does anyone have any questions or thoughts?
Is that are you pretty much 3D printing all of your parts?
Yeah.
Yeah, cool.
Except the base here was laser cut. It may change to be 3D printed pieces interlocking together in the next revision, just so that it will be. And it's PLA too, so in the right conditions you can biodegrade this. And essentially, if we're able to collect all of our robots, we will have the right conditions, or we'll make like a greenhouse with the right conditions in order to biodegrade pieces that we can't recycle in like a Billustruder or something machine.
Is that light on top a beacon, or is it some kind of comms?
It's a beacon, so whenever you're in range with the communication or with the control nunchuck, then it actually lights up and blinks. But a funny story about this, I actually have a dream that this LED, when it starts blinking, if the robots are deployed at night, imagine if there were fireflies and they start syncing with the blinking of this LED. That'd be pretty sweet.
You were talking about how you kind of set it up and engineered it so that it could adjust its own like center of gravity. Like, is that something you'd done before? How did you like think of how to solve that issue and implement that?
It definitely wasn't something that I'd done before, but I was really interested in trying to design a fun drive system. There were two options that I were tossing around. One was being able to do this, and the other one was if you could imagine both of these struts turning out like this so that the robot gets closer to the ground. You could do that. You would just have to add an idler gear to the gearbox. So that was one of the benefits in a way. It's flexible enough to do one of the movements, and then with just adding another gear, you could do the other thing.
Sorry, it's just that's something I didn't. I don't have any work at all with doing things that have to do with like structural integrity and drive systems and stuff like that. So to me, I'm looking at going like, wow, how'd you?
Yeah. So inside of here, there's the servo, right? And that attaches to the drive gear, which, if you could imagine, would be right here. And then that drive gear is then powering these two gears. The gears are attached through this axle that I have. It's just a 1-inch rivet or something. Yeah, a 1-inch rivet that doesn't have a cap to it. So that's why this plate goes onto it to keep it in place. And then the wheels, I'm trying to make them modular, so these ones are attached with dual lock. But for the tank treads, I guess this will be a bit different. Could probably still make them modular if it's using dual lock.
Well, you have to change some of your control software quite a bit for using tank treads. Like, I don't know whether the software for the drive mechanism might be different or not.
Maybe. Probably for turning it will be a bit different. But the thing is that right now, with this wheel design, it doesn't turn very well because these are just coaster wheels. And in the wet sand, it has a really hard time trying to essentially push one of these and then pull the other side when it's trying to turn.
Yeah, I suppose for like tank treads rather than, because you'd have to keep like both on each side. You'd have to keep both motors in sync. But I suppose you could always just switch one off and say with tank treads just use the front motor for driving maybe.
Mm-hmm.
Yeah, that'd be cool. It'd be fun to see that.
I'll probably use the same way I did the hinges on the unfolding CubeSat for the actual treads part. So that will be fun, just multi-material fabrication stuff. It's great.
What are you using controller?
Like control, like as in driving the robot?
No, as in, well, the controller that the operator uses. What do you?
Yeah, so for that right now it's using a nunchuck, like a Nintendo nunchuck joystick, With no buttons pressed, then you're just controlling the drive motors. And then when you hold the big button, then that's moving the arm. And then if you press both buttons, it opens and closes the claw on the other arm.
So how is that connected back to the robot?
It's connected through XB wireless right now.
Oh, okay.
We're eventually going to move to LoRa modules to get more range.
Did you say LoRa modules? What are those?
So it's spelled LORA, and they're these new radios that in North America they run in the 900 megahertz range, and they're now going to be used for like making networks, like mesh networks that are somewhat long range. So you could think in the scale of 1 kilometer about. So for use with this robot, that'll be helpful because we'll be able to make it reach difficult locations when we're just standing the place where we can go. Then the robot goes on further.
Yeah, I've only used XBs, and I really like XBs, but yeah, they're fairly short range, so I haven't heard of LoRa before. Be interested to look into that.
Right, great. Well, if everyone can help spread the word about the Kickstarter, that would be very helpful. Thanks, everyone, for joining in the robot party for this time. It is great to see everyone's robots and progress, and also the theme environment. Hope everyone will keep building on their robots and post up your progress in the community. It's always great to see. So
yeah, I should post links when I actually make progress with my stuff. I have to remember to post up on the Google Hangout group page.
Yeah, definitely. So until next time, keep building robots, everyone. Thanks for joining in.
Yeah, thanks, Erin. I'll check out your Kickstarter.
Thank you.